On today's episode, we are going to be talking quantum security for Ethereum and doing a part 2 AMA with QRL core blockchain developer Kaushal. Let's dive into today's exciting episode.
The world is beginning to witness unprecedented technological growth in areas such as AI and quantum computers. But what does this mean for Bitcoin and blockchain? Welcome to the QRL Live, where we discuss the collision of quantum computing, blockchain, AI, and cryptocurrency, some of the most compelling and emergent technologies today. The field of quantum computers is one of the newest and most promising areas of science, and its implications could very well disrupt our world in unpredictable ways. State-of-the-art machines are being built today that, in the future, could be as disruptive as the transistor, television, possibly even the internet. We can no longer ignore these implications. What does this mean for Bitcoin and crypto? Cryptocurrency, and therefore blockchain, is considered classically secure from modern supercomputers. However, there is a potential vulnerability in nearly all blockchain projects, in that a sufficiently powerful quantum computer running Shor's algorithm could effectively take over the addressing scheme, empty wallets, disrupt applications, and cripple entire cryptographic networks. Scientists, developers, and researchers have known about this emerging threat for some time now, and in response, the NIST has been working since 2016 to develop post-quantum secure cryptography. In fact, the brightest minds in science and cryptography are working on solutions to this problem right now. The QRL project is a purpose-built, quantum computer-resistant, doubly audited, industrial-quality cryptocurrency that uses an NIST-recommended XMSS hash-based signature scheme, which is provably quantum-resistant. So what does this even mean? It means that we develop the blockchain technology of tomorrow in order to keep your digital assets secure today. Welcome to QRL Live. Let's dive in.
Hey everyone, and welcome back to another episode of the Quantum Resistant Ledger channel, the place where you come for the crypto and stay for the quantum. I have an exciting episode for us today. We are going to be doing a part 2 AMA with QRL core blockchain developer Kaushal on enQlave and discussing quantum security for Ethereum. And with me for this discussion today is my co-host, Michael Strike, who is our Director of Outreach at the QRL. Strike, it's great to have you with me.
Greetings all, crypto enthusiasts, YouTubers, quantum enthusiasts, and anyone else I missed.
And also, as I mentioned, Kaushal, our QRL core blockchain developer, is with us for a part 2 AMA. Kaushal, good to have you with us.
Yeah, so it's very interesting, and it's a good thing that I'm having this second conversation with the community in this live VM. Yeah, so it's great.
Backed by high demand.
Thank you.
Yeah, I think where it would be good to kind of just give a little bit of context for those that maybe saw the part 1 AMA that we had a few weeks ago. If you haven't seen that AMA, I'll link it above. So you can easily reference it if you haven't seen the part 1. But what we're going to be doing today for this AMA is we're going to be taking some questions from the community that were clarifying on some questions that we went over in the first AMA, and then we're going to be answering some new ones coming up. So Kaushal, if it would be good with you, we're going to dive right into some community questions in a second. And for those of you watching right now, if you have questions that you want us to answer live in this AMA, throw it into the stream chat. And at the end, as we get through these first questions that came in, we'll dive into some of those one by one. So the first question is coming from Promesied, and I might be butchering the saying of that, but the question for you, Kaushal, is how does enQlave compare to atomic swaps? We'll start here, and then we'll roll through some of the other AMAs in this episode.
Okay, but the question is itself very interesting. It's just because atomic swaps is a different thing, and enQlave itself is a different thing. It's like we are trying to compare here apple and mangoes. So, but no problem. I will still go with this question. So the atomic swap is basically happens between two different blockchains. All right. So it happens when you have a token in one blockchain and you would like to exchange it for another token, which is in another blockchain. So because it is in two different blockchain, we need a cryptographic way to make sure that this transaction happens between these blockchains
Oops.
Is he frozen?
Yeah, I think frozen for a second. So we'll see if
Shaw
he
might
comes
be
back.
frozen.
Yeah, we'll wait a second to see if it comes back on in a second with his feed. Let's see here. While we're waiting for him to come back on in a second, we will pull in a couple other AMA questions. Let's see what we have here. We have
Why don't you
a
run
couple
down
other.
through the process again, Ryan,
Yeah,
of where exactly the questions can be posted? And we can show
yeah,
it back online.
yeah.
We'll have those all prepped
Yep.
up. Oh,
Yeah, I'll do
there's
that in a
one.
second. Yep. Yeah, we have a couple coming in, a few that were on transaction fees, etc. But just for context, if you want to throw a question in, we're seeing some coming in the chat regarding eQRT, so we can dive into those. We'll see. I'm gonna see if Kaushal is gonna hop back on here in a second. So if you haven't asked a question already, just throw it into the chat, and what I'll do is I'll populate a couple of these now, and Kaushal should probably be back on in a second here.
Yep. So I see a question coming in from Darwin and from Stone.
Yeah.
Yep. Okay. Yep. So that
Okay.
process is working. You should be good.
Perfect.
Shape there.
I'll yeah. For just for a second, Strike, while we're waiting for Kaushal to hop back on, can you give a little bit of context? Because there might be a few people watching. Obviously, most people watching already know what enQlave is. But what's like your kind of like elevator definition if someone were to ask you what enQlave is? Just background real quick, and then as soon as Kaushal gets back on, we'll jump right back into the AMA.
Yeah. So enQlave is for any of the newcomers that might be coming here for the first time or are new to quantum and or crypto. enQlave is part of a broader ecosystem that the Quantum Resistant Ledger project is developing in order to take post-quantum security outside of our own native chain and then contribute to the blockchain ecosystem as a whole. What does that mean? What it means is enQlave will allow you to post-quantum secure Ethereum and a subset of ERC20s. So specific ERC20s. There are some requirements such as smart contracts, specific requirements around the ERC20, whether or not it can be post-quantum secured. And there's also enQlave can also, the theory of enQlave, as far as the scope of it and what future generations can be done with future generations, be it upcoming layer 2 protocols, which is a direction in which blockchain's ecosystem is headed, right? Those can be compatible as well. But as it stands right now, the only one of the main requirements on whether or not enQlave is compatible with a existing blockchain is that blockchain must have sufficient smart contract ability, and specifically to be able to handle the code of enQlave, the enQlave, each of its individual subsystems, which obviously Kaushal knows much more about. But all of that means is what we're trying to do is bring post-quantum security to blockchain, to Ethereum.
Yeah.
We want to the quantum resistant ledger is your quantum security policy, insurance policy, right? If you do the research on quantum computers and you're looking at the progress being made, right? There's news coming out every day, and what we see in the viewing audience has heard me say this before. I view this as a bit of an iceberg effect. The information that you see is the tip of the iceberg. I was on the NSA site and I went to their quantum computer page, and I just couldn't find out where they were at, right? As far as the progress that they've made, it seems to be happening. It appears non-existent, but I'm pretty sure it's just happening in a vacuum. Point being, it's not just when we take into consideration the quantum threat, or Y2Q as we call it on the team. We're not just talking about what the public sector is doing. What are nations doing? What are governments doing? What are privately owned corporations doing? That have a strong base. There's hundreds and hundreds of millions of dollars being pumped into this field, right? And a strong argument contrary to that this is a speculative market. It is. That's why we talk about we're not screaming sky is falling. We're saying, hey, this is what the data shows. This is the progress being made. Look at where we are compared to where we were several years ago. Don't go microscopic. Zoom out. Look macroscopic. What's going to happen? And if you think, not financial advice, if you think that there's a 1%, 2%, 3% chance of an existential quantum threat to your digital asset portfolio, then it makes sense, I think, to hedge a small amount in that direction based on what your portfolio exposure risk is, based on what you've determined, how strong you've determined the Y2Q threat to be. So that's how I would describe enQlave. It's an evolving ecosystem. As it continues to evolve, we have a lot of different ideas that we're talking to inside the team, and we're open to ideas from the community, and we're going from there. What you see as far as the smart contract for enQlave, which we've been told is done. It still needs to go through complete an auditing process, is my understanding. But that's not the finish line. I think my own personal feelings is that I'm a strong believer that post-quantum security is probably more a journey than a destination.
Thanks, Drake. I appreciate you covering that. Not only did that give us a little a minute or two for reconnection issues, but it also helped give a little bit of context and background. And so what we're going to do now is where we left off, we were covering the question. Kaushal was diving into how does enQlave compare to atomic swaps? Obviously, apples to oranges. So Kaushal, I'm going to let you take back over, and we'll finish this question, and I'm kind of go from there. And fingers crossed if there's a connection issue. No worries, we're all good.
You're back?
Yeah, really sorry. Yeah,
all right, no problem.
An issue with hotel internet. So I'm using my mobile internet right now. Okay, so I was telling about this enQlave stuff. So the atomic swap is, we already know it happens when we have a token in a different blockchain and we want to swap that for another token which is in a different blockchain. So atomic swap is a cryptographic way to make sure that these transactions happen securely without any cheating. Okay, so that's what atomic swap is for. On the other hand, we have enQlave, and the problem that enQlave solves is to make a non-post quantum blockchain a post quantum secure blockchain. So basically, the main purpose of enQlave is to give you a post quantum security over the Ethereum blockchain. So it has nothing to do with cross chain transactions, so there's no comparison, because atomic swaps works between two different chains, while the enQlave works on the same chain. Like the Ethereum is a blockchain, so it works on that chain. Purpose is to make post quantum secure. Atomic swap cannot make anything like post quantum secure. So that's the difference between these two, and so we cannot compare them. Yeah.
Sure.
Yeah. Thanks for covering that and the distinction between the two. That helps clarify it for the person asking and just in general.
So there's a second question. I think I've got the pronunciation down. I think this is prophesied, as in prophet.
Yeah, I had the same issue with the name, but yep.
Yep. As I looked at it at a second glance.
Good questions.
Why are the transaction fees high on enQlave? Can you explain that? Because honestly, we talked about this a little bit in the last, I think 2 weeks ago, right? And enQlave is enQlave will have ERC20 support, but one of the things that I actually learned on that call that I didn't know at the time, because we're not in we don't have we don't have final product available quite yet that's been published, is that the ERC20 there's some additional considerations as similar to how once you go post quantum secure, there's usually something special that needs to happen. For example, the one-time signatures, right? That's quantum specific. So, but I was interested to learn that there's some differences with the ERC20 as far as transferring ERC20 from one Ethereum address to another Ethereum address and the transaction fees involved. Could you cover some of that for us, please?
Yeah, so last time I remember I mentioned the transaction cost for the hash chain based transaction is around $45, right? And after that, it became a concern like $45 too high. So the value of $45, which I told you, that was at the time when there was a high network congestion, right? So if I tell you, like, if you, let's say if we have launched enQlave at this moment, and if someone trying to make a transaction at this moment, he has to pay only around $29 to $30 for that transaction. Okay. And just 6 hours ago from now, it was around $28 or $27. So this varies based on the network congestion, right? So when there is a very high network congestion, you can even see the price jumping to $55. But right now, at this time, at this same moment when we are making this video live streaming, at this time, if someone use enQlave, then they need to pay just $30. That's all for the transaction. And the reason that why we have this much gas fee, is just because we have some computation, right? We are making it a post quantum secure, so obviously it requires some computation, which is not simple as it happens on Ethereum normal transactions where there's no post quantum security. So obviously security comes with some processing and some cost. It's not something like I can make it completely cheap and without with this whole security. And as I already mentioned you, like $45 is the price when I told you when the network was in very high congestion, and so that's the time. And right now, if you make this transaction, you will do it with $30. I think $30 is sufficient and it's reasonable price for post quantum security. And as I mentioned you, like 6 or 7 hours ago, it was somewhere around $27 or $28. So I think that is feasible. It's not something I think is of a huge concern.
One other question on top of that came as you were talking came to mind.
Yeah.
ETH 2.0, right? Okay.
Yeah.
Sharding, right? Faster transactions, efficiencies, things like that. Have you looked into what gas transactions, if they would be same, less, more in an ETH 2.0 environment?
Well, right now there is no sharding, right? Right now the
Right.
sharding has not been implemented. So at this time it is $30. But yeah, once we will have sharding, you can definitely make an assumption that the gas fee is going to reduce drastically. It is going to happen with the sharding, just because once you have sharding, it's like you have lots of parallel chains, and each of those chains can process some amount of transactions. So it is kind of like you have distributed the network traffic in terms of transaction into different networks. So in that case, uh, you will have even lower transaction what we are seeing right now. But even $30, I think it is still a reasonable amount for a post quantum security.
So, like with any emergent technology, such as what we're building here with post-quantum secure Ethereum,
Yeah.
essentially, we are based on progress being made in the field. We're expecting, can't guarantee, but we're expecting the gas fees and the costs to decrease, much like technology over time. The costs decrease,
Yeah.
right? So,
Yeah.
if you want to go state of the art, these are the fees that it is right now. We have a plan in place and a process in place in which we expect the fees to drop substantially. And granted, that's mostly because of Ethereum's their timeline and their and ETH 2.0 and all the work that Vitalik's done. So I just wanted to add that positive on there as well, that positive qualifier on there. So okay, cool, thank you.
Yeah. No, and it's important too, even to mention on that, like obviously early on to be able to have post-quantum security, there is that trade-off. But obviously as things move forward, as you mentioned, Strike, that gets lowered. But there is somewhat of a trade-off earlier on to be able to have that post-quantum security. So thanks for covering that, Kaushal. We're going to go down. I'm going to pull another question here from the community. Henry Facey asks, why can't enQlave be built on QRL mainnet or some protocol layer of QRL? And have QRL started its own version of smart contracts? Henry's got two questions. We'll start with this one, Kaushal, and then I'll populate the second one.
So the answer is very simple for this one. Is just because what's the purpose of enQlave? The purpose of enQlave is to provide the post-quantum security on the blockchains which doesn't have the post-quantum security inbuilt. So QRL is a blockchain which is itself has a post-quantum security because we are using XMSS hash chain based cryptography, which is itself a post-quantum secure cryptography. So we don't need enQlave for the QRL. Why we need a post-quantum security for a blockchain which is already post-quantum secure?
Yeah.
So so Ethereum is not a post-quantum secure blockchain, and we know there are a huge amount of assets such as ERC20 tokens, Ethereum itself, ERC721 tokens, but these are all non-post-quantum secure. So this is why the enQlave is required to be on those blockchains which are not post-quantum secure, so that we can provide user a post-quantum secure wallet at a cost of some, a little bit high gas fee. Yeah.
Yeah. And Henry's second question on here was if you could transfer ETH into QRL with a system like that, but we can move into the next questions below that. What were you saying, Strike?
Kaushal, for anyone that's we're increasing our user base and adoption has been increasing. Can you just briefly describe, 30,000 foot view, why QRL is quantum secure? What is that compared to Bitcoin? Just briefly.
Yeah, sure. So in simple terms, if I say it's like Bitcoin, Ethereum, anything like these, they use ecdsa cryptography. Okay. So I know it's in layman terms, just consider these cryptography has been proved, like they work on the polynomial functions, and quantum computer can easily crack these polynomial functions. Okay. So because there is an algorithm which if you run on a digital computer like the computer or the laptops that we use, it for in order to run that algorithm, it is going to take like millions of years just to crack an ecdsa keys. And that's the problem with digital computer. But there's a source algorithm, so if you use that and you run this same algorithm on a quantum computer, it can crack it depending upon how much qubit it is of. But if we assume like 2000 qubit computer, it can crack it easily, maybe 1 or 2 days maximum or something like that. But so that's the problem with the polynomial function. So these are trivial cryptographies are based on polynomial function. Our cryptography, which is XMSS extended Merkle signature scheme, is a hash-based cryptography. So I don't know like how many people know about this hash. So hash is, in simple terms, it's like you can give any size of input, could be like 50 lengths of input or 20 lengths of input or 30 lengths of input, any random size of input, and it gives you an output of a fixed size. So let's say if it is hash SHA-256, then you get a 32 bytes output. So basically for one output there could be like infinite inputs. There are infinite possible inputs for just one output of 32 bytes message in the hashing. So this is why the quantum computer doesn't have any algorithm from which it could derive the actual input which resulted into a specific hash. And because there are infinite possibilities of these input which can give that a specific hash, this is why they cannot crack it. And because we are using XMSS, which is a hash-based cryptography, and as I mentioned, there is infinite input for a specific hash, and that's why we say like it is post-quantum secure, and it's not just like we say it is a post-quantum secure. It is also backed by, like we already know it has been approved by NIST. Like XMS is actually post-quantum secure.
So to summarize all of that, you're essentially saying that instead of using asymmetric elliptical curve cryptography, public-private key
Yeah,
addressing scheme, we're using a hash-based addressing scheme.
yeah, that's true.
So we're not using ECC, we're using hash functions to
Yeah,
break it
that's
down
correct.
into its most basic component. If anyone that's viewing within the audience wants to research the difference between elliptical curve cryptography and hash-based hash-based signature schemes. So thank you.
Yeah.
Yeah, let's move into Strike. Let's pull up. We got a question here from a couple ones coming in from 0xFF. We got one on OTS tracking. You want to move into a few of these for Kaushal? More AMA ones here. We got this one here, Strike.
Yeah, go ahead and run past that one. My computer's acting a little nuts right now.
Yeah, this is coming in from 0xFF. And the first part of the question is, actually, he's got a few questions, so we'll go through them. How will OTS tracking work with enQlave, and will users need to track manually the OTS index to have safe backup and restore process? So kind of two questions here for the first one. I just populated it here.
Okay. So in case of enQlave, the OTS things are still going to remain same as we have in QRL blockchain. So we have a map into enQlave. So each time you use a specific OTS index, we just mark it in the bit field that it has been used, right? So if someone tries to use an already used OTS index, the smart contract will detect it. And if you want to confirm like you have used a specific OTS index or not, you can make that confirmation without making a transaction. Okay, we have a function which is a kind of view type. So basically a view type is like you do not need to make a transaction. You can simply make a query to the blockchain, and this query happens via API or something like that, and then you can know if that specific OTS index is used or not. It will that function will return you true or false. So if it is used, it will return you true. If it's not unused, it will return you false. So we have that function. So someone wants to make a query, it hasn't used or not, then they can use that function. But it's like it is a map. So if you want to know the bunch, like the list of OTS indexes which you have used or not, you want to get the list, then it is like you need to make query for each of the OTS indexes. Is this one used? Is this one used or not? Is this one used or not? Unless you reach to the point where it says, okay, this one is not unused. Even then, as we have one problem which we already discussed in QRL and before, it's like sometimes what happens is like you made a transaction, you thought that transaction was valid. Maybe you have some input which is not valid, or maybe you broadcasted the transaction with a fee, but your account doesn't actually holds that much amount of quanta to cover that fee. Right now I'm telling you in terms of QRL blockchain. So what happens is like you signed your transaction with an unused OTS key, but you mentioned a fee which your account doesn't have to cover that much amount of fee. In that case, the node simply reject that transaction because you mentioned a high amount of fee and you don't have that much balance to cover that fee. The problem is you used an unused OTS index, right? But because transaction was dropped, that OTS index was not marked as used. And if some network at that time, then he can just record your transaction. So Next time you make a different transaction with that same OTS index, then the problem is because you are reusing that same OTS index, and because it was not marked as used last time, the transaction will get processed, but because you signed two different transactions, one which was failed in the past, and second you signed a new transaction with a different fee or something like that. So this creates a security issue. So usually the best practice is, if you have used an OTS index, you should mark it manually. Even if the transaction fails, you mark it manually that, okay, I have used this one and I'm not going to use it in future. So that's the best practice. But uh, if you know, like, your OTS index, you never had the issue where you have signed something with an unused OTS index and the transaction didn't fail, in that case it is fine, you can rely on the network. But usually the best practice is that you maintain what OTS index you have used in the past. Yeah.
Thanks for diving into details on that one, Kaushal. That was helpful and good question.
Yeah, thank you.
0xff. Strike, are you able to see now if I pull up the next ones here? It looks like we got a good one. We got one on liquidity, another one on one-time tokens. I'll populate the liquidity one for you here.
Let's do it. We got one more. My word had crashed on me. I guess that's an indicator that I need to switch to Linux. 0xff has a second question. He's asks, is the goal of eQRT to provide liquidity to QRL? If yes, do you think the $45 transaction fee will be a problem to create this liquidity?
Okay, so as I mentioned like a couple of minutes ago, $45 was the price when I looked into during very high network congestion, right? Right now it is around $30, and 6 or 7 hours ago it was around $28. So $28, $30, $45 is not a big issue for anyone using post-quantum secure enclave wallets. So I'm not considering the $45 will be a big issue, but yeah, in most of the time you will be having a fee somewhere between $30 to $35, somewhere around that. And talk the next question, which is like the goal of eQRT. So basically the goal of eQRT is to have a wider reach. So earlier QRL was itself a token, and then we migrated to mainnet. So because we didn't have a way to make a post-quantum token on Ethereum blockchain. But right now, after so much research and testing and the work, we now know that we can have a eQRT token on Ethereum blockchain with post-quantum security and at a reasonable gas fee. So this is why we have it on Ethereum, and the main purpose is to expand our reach, to have to let's have people who are comfortable using Ethereum blockchain. Let's have them to be the member of our community. So with eQRT, I think the main issue is to have a more wider audience, better reachability, and liquidity is something which I leave on the market itself. I believe if we have more reachability, wider community, then liquidity will automatically improve with the time.
Yeah, it'll be a byproduct. Yep.
Yeah.
Ryan, looks like there's a question from our users. Has there been any collaboration? You want to take that next one?
Yeah, we got that one. We got one on institution. Let's jump to this one here. I'll populate it here. Has there been any collaboration with or input provided by any of the core ETH developers on enQlave throughout the process? And Strike, do you see who that question came in from, just so we can?
It was one of the pre-populated questions. Okay, yeah. But I'm just moving forward a little bit because I want to make sure we get to our live questions from.
Yeah, we got quite a number of them coming in. So
we got a lot of stuff coming in. Yep.
Yeah. Yeah, Kaushal. So if we could cover that one first on Ethereum devs and just answer that one, then we'll keep going from there.
Yeah, sure. So we didn't have collaboration with anyone else. So it was only our team members. We did our own hard work, our own research. We didn't have collaboration or any kind of input provided by any third party or any core Ethereum developer. So whatever we have done in terms of enQlave, it's our own. So it's nothing like we have taken help from anyone else outside of the QRL organization. Yeah.
How does Geometry Labs fit into that as far as assistance?
Geometry Labs is working basically on proof of stake. So basically, are we are looking for way to aggregate the post quantum signatures on proof of stake network so that we can reduce the block size. So that's where we are working with the Geometry Labs.
Thanks.
Yeah.
Yeah, thanks for covering that one. Let's jump. Do we have one more down here, Michael, on
We do.
technical goals? Want to answer that one,
Yep.
and then while we do that, before we jump into this question for Kaushal, if you have any other questions, we're already seeing a number of them in the chat. If you have any other ones, feel free to throw them in there, and we'll start jumping through a few of those in a second. But I'm going to populate this one for Michael here, and I'll read it out. And what are the technical goals of the planned POS system? TPS, proof of stake style, stake requirements, and even a rough timeline in general. There's a lot baked into this question. Do you want to cover this one briefly, Kaushal, and then we'll jump into some of the live AMA?
Yeah, it looks like they're asking about how transactions per second on
there's a lot
our
in here.
flavor of proof of stake. There's a bunch of different flavors, obviously. Nominated proof of stake, XYZ. So, yeah.
So in case of the proof of stake, our first goal is to make it more decentralized. And the way that we can make it more decentralized, so there are two ways to do that. One is to reduce the amount required to stake. So instead of having like 10,000 quanta, reduced to 5,000, or even reduce the amount like even lower than 5,000. And second way is to have lots of validators. So we were targeting somewhere around 10,000 validators for the proof of stake. So these are the two main goals that we are looking for. TPS is something that we are thinking that we will cover it maybe in the after that. So but the first priority is to make it decentralized as much as possible. So as I mentioned, these are two requirements. One is to reduce this stake requirements so that we can have more and more validators to join the proof of stake. Second is to allow as much as possible the number of validators as much as possible in the proof of stake. So 10,000 is a number that we thought of, but then the problem which comes up is in proof of stake, you have a block and you need to get signature from all the validators voting for that block. Okay, so that vote basically act as a proof that okay, that sufficient amount of validators has actually voted for this block, so this is the part of the main chain. Now the thing is we are using post quantum secure, so we are using basically post quantum cryptography, so our signature size is huge. And if we go with like even if we go with like 100 validators per block, and if you consider the signature size of XMSs, which is around 2 kilobytes, like 2.15 kilobytes, somewhere around that. So 100 such validators, if they sign for a block, then the block size, just considering their signature itself, becomes around 215 kilobytes. So we know like the block size just for the at the protocol level will take at least 215 kilobytes, just as the in the name of vote, to make sure like this is the part of the main chain. Now if a minimum block size become 215 kilobytes, then you know the room for the transactions, if someone makes the transaction 100 or 200 transaction, block size will become around half an MB. Half MB block size is still way too big. So this is why we are taking help of the Geometry Labs, where we can aggregate this vote signature, so we can reduce that from somewhere from 256 kilobytes to further like maybe 100 kilobytes or something like that. So we are looking into that possibility, and Geometry Labs is working on that. But if that's done, if if we can have a post-quantum secure aggregatable signature. Right now we have aggregatable signature, but they are not post-quantum secure. So if you use them in our POS system, then we will end up with like other blockchains which are not post quantum secure, and this is why it is taking a little bit of more time than what we expected, because if we just launch it with whatever we have done right now, the blockchain size will become pretty much big, and in long term it will be like, like 10 or 20 times whatever size we have of our current blockchain. So that's why if this problem gets solved, then rest of the things are very much easier compared to whatever we have right at this stage, because we have to reduce this blockchain size. If we do not do that, then that will have an impact on network, that will have an impact in block timing, because half an MB block size is still way too high, and the blockchain size, like if we have somewhere around 1 minute block timing, then I think uh, half an MB block size, I cannot suggest to go with 1 minute block timing. In that case, we need to increase the block time too. So that will also reduce the TPS. So that's why we are looking if we can reduce the size of this vote signatures and can end up with something more reasonable with the post quantum security. Yeah.
Thanks for covering that one. What we're going to do now is me and my son Michael, we're just going to look through. We got some questions in the chat here. We can pick and choose a few of these ones. While we're looking at these, thank you to everyone in the community for throwing in some questions here, and also some of the ones that we already went through. Michael, let me know which one you want me to populate here, and I'll pull it up for us.
Oh, let's cover one by Merlin Moon.
I see it right here, popping it up right here on good question too on wQRL question.
Yep.
We got it right here.
Yep. Why was the name changed to wQRL instead of eQRL? That made it clear about the difference between Ethereum and enQlave.
Why the name was changed? So I don't have any idea with the name. I think someone from, like, if you guys can explain that better, then it will be better.
I might be able to.
Yeah. How would you, Strike, how would you define that? I think it's more of just you're thinking of it long term with like how people within the crypto space kind of are perceiving it. And there's just, as it goes on, we don't want it to be so complex where it's like, well, what's the difference? We kind of want it to, give me your definition.
Sure,
on
I
it,
can attempt an answer on that.
Yeah.
So as a team, we were discussing the acronyms and the prefixes to those acronyms. For example, lowercase w and then uppercase QRL. And one of the things that we talked about was everybody knows what lowercase w, capital BTC equals, right? It's wrapped Bitcoin on the Ethereum network. What is not as well known is what eQRL. Okay, so I know what a dub is. What's an E? And one of the things, we're already at the intersection of blockchain, quantum computers, and post-quantum security. One of the discussion points that we have on the project is anything that we do moving forward, we are trying to make sure that the skids are greased for adoption. We don't want to seem intimidating. Quantum computers, blockchain, they're already intimidating. Even if you're a blockchain veteran, you can jump into this space and get overwhelmed by post-quantum security, and that's easy. So we thought that wQRL was a better match as being wrapped QRL than eQRL, which is Ethereum QRL. So we thought that was a better match. While it doesn't necessarily completely 100% accurately explain the fundamentals behind it, it's the difference between being an engineer and getting the message across. So you may hear me say sometimes any communication that is 100% technically correct but not understood by the audience is 100% incorrect. So as I recall, that was why we made that change. That's my memory anyway. Who knows?
Yeah, and it's no. Thanks for covering it as much as we can, or at least spitballing in real time on it. Let's see what other questions we got on here, Michael. Which other ones you want to pull up here? We got one from. We got a couple at the top here from earlier. Stone, Darwin. Which one do you want to populate here?
Let's see. We have looks like we have a Sean Dillard who's posting. That's huge, broskies. I don't think that's a question.
Yeah.
All right, let's go down to the next one. Okay. Is QRL envisioning a post-quantum future where vintage ecdsa NFTs will be wrapped in enQlave? CryptoPunks and other NFT art will be marketed, traded as post-quantum. Okay, so we have this. We've talked about this on the team a few times. We've got this NFT, and you have two schools of thought, right? You've got fad, or is this a legitimate long-term market? And I think Ryan, you and I were talking about this, and you, Jack,
yeah, we were talking about it.
Peter and I,
we were talking about it yesterday, and like I think that if we trace back to I don't know the .com bubble, or even with social platforms in the late 2000s. Or if it was the ICO craze in 2017, 18, or what's going on with NFTs now, there's a lot going on in the space. And what's going to end up emerging is there's going to be a lot of projects. I don't know, I'm just making up ballpark numbers, but 95% of stuff is going to go to zero. But that doesn't mean that great stuff's not going to come out of it. There's going to be a lot of really good things that come out of it that are, emerge over time. So I think that just dismissing it and saying it is fad would be very would be a bit naive, because obviously there is something that is tangible there, and there's a lot of use cases that actually make a lot of sense. But I think that's kind of at least how I'm seeing it. And I think that the way we view it right now, of how we view how NFTs are in 2021, there's going to be so much more unlock over the coming years. We're already starting to see little signs of it, but it's not going to be in the exact flavor that it is today.
So here's the thing. And when you say fad, you think of something relatively
you're thinking like Beanie
right?
Babies or something.
Beanie Babies, but I think when we were talking about it, I just playing devil's advocate, I brought up the reference of what hacky sack, right?
Yeah. Or Pet Rock.
I'm probably aging myself. Well, okay, there you go. Pet Rock. I don't remember that one. But hacky sack lasted for 3 decades, and that was considered a fad. So if you call it a fad, I think that's a very subjective term.
The internet was a fad.
The point being, if NFTs last a decade, is that still a fad? And if not, even if it is considered a fad, that decade could give credibility to a lot of investment opportunity, right? And I will concede that I haven't said this in Discord. I'll concede to this one thing. I do own at least one NFT. And the reason was because, first off, I wanted to go through the process. I wanted to understand the NFTs. And there's also, and this is my personal feeling, there's something intangible, it's kind of like super nerds trading baseball cards.
Yeah, and
right?
I like to, yeah.
And I kind of like knowing that I own this one thing, and if it turns out to be anything like 3-letter domain names in 2001, I don't have to do anything. Yeah. So what I look at NFTs as low risk, low cost, with the possibility of a potential moonshot, especially for earlier ones. Now, I did see online that everyone's coming out with NFTs. There's a site where you can go on and generate random whale FFTs, and they've got different accessories on them and things like that. But let's be honest, this is crypto. This is NFTs. Who the heck knows what's going to happen? The space gets nuts, right?
Yep.
All bets are off. You just don't know. So if you see an opportunity and it's low risk, sit on it for 5 years. See what happens.
Yeah, and just as my last closing thought on NFTs, it's human nature for people to collect, to have. I think it's going to be even a sign of like a status thing of being like people ask you, hey, what kind of art do you own, or do you collect? Maybe someone has like relatives or someone that collects memorabilia or coins or whatever from the past. It's just going to be a thing in the future where it's like, oh, like you hold certain digital assets. It's just a progression. It's the same thing. History doesn't repeat itself, but it does rhyme. It just follows along that. So
NFTs remind me of precious metal coin numismatics.
Yeah.
Almost,
so let's move
right, like a special coin. All right, go ahead.
Yeah, let's move to, let's see if we got one or two more questions on enQlave here to wrap up this part 2 AMA, and just let me know if there's a certain one you see here, Michael, and I will I'll populate it for us as we wind down the end of this AMA.
Go ahead and pick the next one.
Okay, let's see here. I'm populating. Let's see. Let's pop this one in. This is from Discord. Want to give more input on having on-chain NFT support for QRL? We have a QRL improvement proposal, Quips poll 28. Do you want to cover this one briefly, Kaushal? This one coming in from the QRL Discord.
Yeah, on-chain NFT support. Yeah, we had a QIP, which I remember was written by Peter itself. So the NFT is possible in QRL with certain functionalities that you need to use. And in QRL, it is much easier because you do not need to write any code. You can simply create a token, and you can have that amount of that total token could be just one, and that address of that particular token could be considered as an address of that specific NFT token. So in QRL, we can still have that, and with some with some like APIs, like with some extra APIs which could make things easier for users to keep track of all those NFTs, it will become easier for to use NFT on QRL. But yeah, right now whatever we have is sufficient for someone to create an NFT token. They just need to create a token using the wallet, and they just need to mention the quantity as one, and in that case that token will itself act as an NFT token. Yeah.
Thanks for covering that one. I'm going to populate one more here regarding, and I'm going to fine Daniel 10 QRL for misspelling enQlave, but I appreciate the effort and questions here. Daniel, good question. This one's kind of two parts in here, but I think I want to, I'm going to read through it. Let's just cover this, the first part of how user-friendly will enQlave be, and I know we kind of already talked about, the quantum security aspect, but could you briefly touch, Kaushal, on just kind of the user friendliness and maybe the UI of enQlave? Because this is really important, whether it's someone that's brand new that I'm introducing to enQlave, the project, so it's not intimidating, or if it's someone that's more well-versed. Just cover maybe the user-friendly portion of enQlave. This is a good question.
Yeah, we've got like 45 seconds at a website before someone gets discouraged and then moves on, or whatever that official number is. Yeah, so please.
Thanks for asking that, Daniel.
Yeah. So JP is working really hard on that part. I mean, the UI is the part which we are not we, but I will specifically say that JP is working very hard on that, including the development of the mobile app as well as the web application, so that users can easily generate, sign, and keep track of their keys. So it's JP is working on that, and that's where we are taking more time. So we are taking more time is just because we need to understand, like, the UI should be something so that anyone can easily understand it. Everyone knows like what they need to keep backup of, what they need to keep copy of, and it should be something like if someone wants to sign the transaction, they can even do that using a mobile wallet, maybe by some kind of QR code scanning, something like that. So it is being worked on at the back end. And as I mentioned, JP is working hard on that, and it will take time, but we are keeping this as our priority to make sure that the UI is something which could be easily understood by the users or any new users who are using this enQlave thing first time.
Thanks for covering that. That's good to cover for people, because obviously they want to know, hey, what's the usability like there. So thanks for covering that one. Michael, is there any other ones within the chat that you want to cover as a closing wrap up? I think we've covered quite a number here.
I think we're approaching last call.
Yeah, we're hitting about an hour and a second, so we'll see if there's maybe one more in here. So
I got another one.
Yep.
Sean Dollard, real estate and blockchain game lands will need to be post-quantum. I think what it's asking is, can we enclave that? I think what it's asking is, as far as use cases for post-quantum and enclave, is real estate a market for that, or what are the limitations there? I guess I'm trying to extrapolate a little bit, but that's what it does. How far is the use case scope?
Let's just talk in general broadly on this.
So in terms of blockchain game, the most of the blockchain games are using NFT tokens, right? Which is ERC 721 tokens, right? And even in case of real estate, I'm seeing like it's some real estate projects which are creating ERC20 tokens to represent the real estate in terms of shares. And some of them are creating ERC 721 tokens to represent real estate as an NFT token. And in case of game, as I already mentioned, they are mostly using ERC 721 tokens. So enQlave is already meant to support ERC20, ERC 721, ERC 1155. So enQlave can support all these types of tokens. So if you have NFT tokens, which is related to the game blockchain, or if you have ERC20 or ERC 721 tokens, which is from the real estate, then you can pretty much put that inside an enQlave wallet and can make it post-quantum secure.
Thanks for covering that one. I think we're hitting about we're hitting about 58 minutes here in a second. So just kind of in closing, Kaushal, thank you for going through kind of a smorgasbord of questions today on enQlave, on quantum security for Ethereum, and talking maybe on just a couple more broader futuristic questions. But myself and Strike and the community appreciate you first off coming on to answer some more questions. I know we were excited after the first episode to be covering some more of these. So thank you for that first off.
Yeah, I just want to add in. I've been on these AMAs before too, and sometimes my questions don't get answered. If you have further questions, jump into our lively Discord community. We've got a lot of passionate members in there, and the team's really good with asking questions. Jack is on top of everything. If he gets overloaded, then I pick. Then I try to jump into. But we have a lot of excellent, very knowledgeable and intelligent people in our Discord community. So if you have something that remains that we weren't able to cover today, jump in there, ask the question. You can find the link on Ryan, our YouTube channels. Right. Yeah, you can link there below this video. We'll have all the links to not only our Discord community, but just to all of the stuff and links regarding the QRL project in general, whether it be to GitHub, whether it be to our documentation, which we're further building on coming up really soon. And then obviously if it's enQlave.io, it's all below in the description. Or if you just jump in the Discord community, you'll navigate your way around there. But if you haven't already done so, I'm sure a lot of you watching this have already subscribed to our QRL show right over my face here. Make sure that you subscribe if you haven't done so already. That way, when we come out with new episodes, you're the first to be informed. And Kaushal, appreciate you taking the time today to discuss all things enQlave, quantum security, and how it's related in this whole crypto world. So for myself, Strike, and Kaushal, have a great rest of the day. We're going to hop off and quantum secure some Beanie Babies, Pet Rocks, and Hacky Sacks. And we will see you all. Hula hoops. And we'll see you all in the next episode. Take care. See you guys.
Goodbye.
Thank you.
Thanks.